Hello Gophers and welcome back to part 11 of Introduction to Go. In this video, we'll be majorly learning about arrays and slices in Go. Before we move forward, please do not forget to like, share and subscribe to our YouTube channel. Also press the bell icon so that you don't miss on any new notifications of any new videos or tutorials that we put forward. So now let's start by understanding arrays on the first side. So, an array is a collection of similar data types. This is a definition that you might have heard if you are from a coding background, like you might have used C, C++, Java, or .NET languages. So, array over in Golang is also similar. Here, how you can declare array is like this, where this is the size of the array that you are mentioning. This is the data type of each value that can be contained in that array. So it can be like int 16 or int 32 or int 64, uint, anything that you like. So currently I'm just mentioning like int to be very generic over here. And in the curly bracket, I will mention all the five values that I need to assign. I can actually skip any value and I can also try to print that. So in array, any value if not initialized will be assigned a value of 0. So all zeros will be assigned. So if it is a string array, then a blank value will be assigned. We'll see how that can happen. So right now I will assign a value to all five variables in the array and we'll try to print the array. So let's try and print this. So I've got 1, 2, 3, 4, 5 as I have mentioned. So if I give some in random order, then also it will maintain the order in which you have actually provided the value. So the first value I gave as 5, then 1, then 3, 5, 1, 3, 4, 5. So it's the same sequence in which you have provided the value. So if I remove this part and then try to run this, it will be assigned as 0. So if you see the fifth value which was not there is assigned as 0. But if in case you want some middle value like this position, that is position second to be precise, so you will have to mention this specifically to be 0 so that Go knows that this is the position that it needs to assign 0. So this is one way of assigning values to an array. You can have a case where you don't have values on the time when you are declaring the array. You might be taking inputs from the user or maybe getting some values from the API. So anything that might come to your mind. So to do that, we can also like I am declaring a variable x which is of type array, which is having a size of let's say 3. And now I will try to assign values to all elements in the array. So to assign all values in an array, we need to use the square bracket syntax and where we'll mention the index number of the value that we need to assign to. So the first value is always referred to as zero index because the number of index starts from 0 in array. So I'll give it as 15, then x of 1 first. So first array 1 means actual second position that a normal user who might not be aware of this concept might see it to be, let's say 98. Now let's try and print this print f values in x percentage v and x. Now when I have given this and let's run this. So values in x are 15, then 16 and then 98. So it's in the same order that we have provided the values. What happens if I have not given this value? So this will be 0 as it was there in the first syntax. So you can see that the last value has become 0. Indeed, you could have done like this. You might have provided the value of the last index and the first index, and the middle would be 0 in this case. So you can see this, that the middle value has been 0, because what Go does is it will always assign 0 to all values in an array when you are initializing it. And then when you are copying the value or putting the values in array, it will replace those. You can also directly go ahead and print the value of particular index or access the value of particular index. That is also possible. If you see value of x on first index is 0 because we have not given the value over here. If I give 16, it should print 16 over here. So this is how you can access the value. This particular value is behaving as normal variable. You can do all type of operations that you might have done on a normal integer variable. So you can add it to 2 in some later part. Let's say x of 1 plus 2, and let's store it to again x plus 1 only. So this will increment the value of x plus 2. That means now x plus x of 1 should print as 18. So if you go and see, x of 1 which we have printed is coming as 18. So all sort of mathematical operations that are possible on any normal integer variable is also possible on a single index of an array. Now, in an array, you can also print the values using loops, which we have already done in our previous video. If you have not gone through the video, please feel free to press the I icon on the top right corner of the video. Now, for if you see for loop, we have one more particular uh, let's say keyword which will help you in getting all the values from a particular array, that is range. And this range will give you two output which will have one. The first one will be key and second one would be value. So that range is providing me with two values, that is key and the value. So I can directly go ahead and print this. Let's see what happens. You see, so key 0, value 5. So here I was accessing the value of amounts array, that was this one. So if you compare the values, you can directly see. So key 0 is 0 index, value 5, first index value 1, second index value 0, third index value 4, fourth index value 5. So this is one way of accessing the values. You might not want keys to be printed, that's okay, but then you need to use the assign only variable, that is underscore, or write only variable, and then remove this key to be printed. I'll only print the value over here, and let's see if we can run this. So over here I can get only the values. Similarly, if you only need the keys, you can also do that. I will mention key, but then as the value is on the second variable, you also don't need to assign it to an write only variable. You can directly go ahead and remove it. Key is this, and let's see what key values we have. So key would have 0 to 4. Similarly, you can also use a for loop which says that range, sorry, I had 5 values, so let's go ahead and do this. So I have initialized an I or in iterator variable to be starting from 0, because I know array index start with 0, and it will be less than 5. I should run the loop till the I value is less than 5. So as soon as it goes 5, I cannot find any index with 5 in this, because the last index would be 4 in our case. So value 5, and every time you complete the loop, we will increment the i's value to 1. So index, I'm printing index and the value at that index. So if I run this program, uh, I think we might have, okay, index 0. Okay, I have missed the slash n, that is why it's printing bit weird. Now let's see. So printing using range was this, and then printing using loop. So index 0 is having value 5, index 1 is having value 1, and so on. So these are pretty much ways that in which you can access the value of an array or assign values in an array. Now with an array, you also can copy the value to another array. So you should be very careful about that. Now I have an array, let's say amounts, and I am copying it to, let's say, deductions array, and I copy the value completely. Now if I directly go ahead and change some value, let's say at index 0, I give it as 56, and then I try to print this. So to print this, now let's try and run this. So the first value has been changed to value 56, which was 5 in the initial array. But in deductions array, I have written the word wrongly. So in deduction array, the first value is 56, and now let's try to print the the amounts also, and let's see if there is some change in amount. So the amounts array remains is as it is. So if you come from other programming backgrounds, let's say Java or .NET, you might have observed that when you copy one object to another object, let's say one array to another array, this this is not exactly value copying. It will copy the reference of the variable. So when you change some value using the reference variable, it will also impact on the main array also. But in Go, the arrays are treated as a single value type. So that is why it will copy all the values that is contained in amount and put that into deductions array, and will create a new let's say a new area in memory for deductions. So there will be two different places where these two values will be stored. Deduction will have its own value, and amount will have its own space in RAM. So that is why when you change something in deduction, there is no impact on amount. Okay, so this is how you should actually treat arrays, but you should be very careful about this, because when you have a larger array, let's say you have a lakh values stored in one array, or you have a heavy object array, let's say you have what do we say, employee record. An employee record can have like 100 fields altogether, and you have a list of 1,000 employees. So this data structure, this data is of very large volume, and when you copy this structure to this complete array to another array, the memory utilization of your program will become double on the same part. So you should be very careful about that. But if you want to ignore that, you can definitely use pointers, which we will be discussing in our later videos. So I'll cover this part in that segment so that you don't get confused over here, because pointer is a very tricky concept that you might be thinking of, because in C we have many operations in pointer which are not there in Go, which makes pointer analyzing or pointer using in Go much more simpler as compared to C or other languages. Now let's move forward and let's start by understanding slices. So now let's start by understanding slices in Go. So let's first remove everything that we have written till now. Now let's say what slices are. So slices are actually an array, but with an array which can have different length on it. So you can definitely append new values anytime, and the size is never fixed. So in array we have a fixed size of object, or let's say fixed memory size that should be allotted, but in slices we don't have the fixed size of memory that is allotted. You can anytime add more elements and work with that. So let's create and slice, let's say names, which so the syntax for slices is pretty much same as it was there for array, just the size of the array is to be skipped completely and rest all remains same. So let's say Ram, Tom, John, John. So this is an array and this is a slice, and now let's start by printing the values that are there, names, percentage v, and let's also print the size percentage d over here, names, and length of names. Now let's try and run this program and see. So the names are Tom, Ram, Tom, and John, as in the same sequence that we have given, and size is 3. Now, if I want to add one more element to the slice after this, so names is equal to sorry, append names, append the slice name should be provided over here, and then the list of values that you might want to add. Let's say uh, Sham, let's say Geeta. So I want to add two values to the names array. So I have given comma separated values, and now let's see and print what values are there. I missed on backslash n, backslash n. Now let's see. So initially the size of array was 3, and now the length of array is 5 because we have added two more values to it. So this is one thing, but we also have a cap function in Go that can give you capacity of values that can be holded in an slice. So capacity, let's say percentage d, and now run this program. So we'll understand what is the difference between capacity and size. So over here I can see the capacity to be 6, but the length is 5. So what is the difference between capacity and length? So in Go, normally every slice will have an underlying array assigned to it. So Go actually is working with an array. So when you append an value to an array, so to an slice, what Go will do is it will copy the values in the initial array and take the new value, see what size of array it has to be declared, and it will copy all those old values, then take the new value, add to new array, and destroy the first one. So we should be very careful in declaring size of our array, the slice. So in slice, we can also declare slice by giving the capacity that it should hold so that we can prevent this copy operation. So this copy operation will normally happen when it does not have capacity to add more objects or more values to the slice. So in that case, it will copy the complete value from the underlying array to new array, creating new array and then copying the value. So if you see capacity over here, so let's see what capacity was assigned initially to names. So if we see, initially the capacity and size were same because when we initialize the slice, we have given three values. So at that time, what Go has done, it created an underlying array which had capacity of 3 and stored a value of 3 values in it. So at that time, length and capacity remained the same. But as soon as you used append function, what Go did is appended two values, but every time it appends a value, it will increase the capacity to some part so that for further operations, it can prevent that copy operation. Now this is something that Go has decided so that to lower down the copy operations to a bit. So that is why you can see the size is 5, but the capacity is 6. So if we add one more object to the array to the slice, it will not actually copy this, but it might happen that it sees that the capacity is getting full, so I should actually copy it to new array and then increase the capacity of the underlying array. So be very careful in using your slices. So when now how to avoid this copy operation when you have a larger size of slices. So you have a built-in make function. Let's say I have uh, same example we can create, and let's say names I will give as make. Make first argument would be what type of object you want to create. I want to create an object slice which will of type which will have values of type string. What would be the initial size that you want? So initially I want length of 3, but the capacity should grow up to 10 values. I know that my slice can at least go up to 10 values. So the underline arrow that you create it with size of 10, but initially I want 3 values to be stored. So I have done this and now names 0. So anything that you can do with an array, same operations you can do over here with uh, slice as well. So indexing and everything is possible similar to that in array. So let's do this, copy this. Now let's see what we get in print. So initially on the first part the size was 3 but the capacity remained 10, and when I had the append operation it also added two values to it, making the size as 5, but the capacity remained same. Because now Go knows that I have ample of capacity with me still to store more values, so it did not copy and create more spaces for further elements to be adjusted. So this operation is much more faster than the earlier one. So I would suggest you to use the make function when you declare slices and use it wisely with capacity part so that your program does not get slower with more values, large values there. Okay. Now let's also understand how you can do some uh, push or pop operations with array. So now push we know how we can do is we can use append directly, and by append I can also do an concatenating of two slices. Let's say I have one more slice with name as temporary name, and it is a normal slice which will have string values, and those string values can have like two values x y z and let's say a b c. Now these two values I want to append to my names array, to my name slice. So how we can do it? So we can directly go ahead and give the temp over here. This will give us an error because the append function is actually expecting primitive data types. Let's say normal data type, it would not accept an slice over here. But if you know in TypeScript, if you might have used in TypeScript, we have an expand array syntax that we can use in normal TypeScript, we can use triple dot, which will actually break down each element that is contained in the array and create it, explode it separately, separate apart. So over here in Go, these three dots are added after the name of the slice. So this will work as as expected, and it will append two values, that is XYZ and ABC, to the names array. So that is how we can concatenate two slices together. And now let's see how we can pop or remove from starting or remove from the beginning of an array, of an slice. Let's say I have x x as a slice that needs only value or only removal of the first name, and it needs everything apart from the first value. So what we can do is names, then I will say that you start with the first index and go up to the end. I will not give the end index over here. So that means it will actually start with this index. So zero index will be skipped, and everything apart from that will be copied to X. So over here, be very careful that slices are reference type variables. So by reference type variable, what I mean, I'll just demonstrate that as well. So size, capacity, X, X, and let's say X. So X contains all value except the first value that was there in the slice. So this is how we can remove the first value. If we want to remove the last value, then how we can do is names. You can start with zero index, or you should not mention zero if you want. And then I want everything that is in length names, in the slice names, but minus 1. So this is how you can give. And so let's go ahead and print y. Let's print y. So from names, it has removed the ABC, which was the last value that was there in names array, and put everything apart from that into the X. Now if I want to remove the last two elements of the array, let's have Z. So last two element, I know we have five elements, so I want to remove the two elements. So I want to go to index, till index what value, 0, 1, 2. I want to take values up to second index. So I will mention 3. So number of values that I want at the position index that I want, plus 1 has to be mentioned over here, because this is excluding this index, and the first part of the colon is including that index. So in this way, when we copy and let's print Z. So now let's print Z. So Z has all values apart from the last two values. So it had contained 0, 1, and 2 indexes in it. Now, what happens when we want to actually remove one element, middle element, from an array? So in that case, we have to do an concat operation. Let's say I have an array A, which should have all values, but only removing the middlemost value, that is index 2, that is John in our case. So how we can do is, you can use append, and the initial slice we can give. Initial slice is of names. Name should have all values apart from index 2. So index two here when I mention 2, that means it will take value 0 and 1 only. 2 will be removed from this. Now I again want names. As I'll start with index 3 because here the first thing that is mentioned means that is including 3. So I want the third index and I will go till end, so I don't care about the second part of the colon. Now I will give 3 dots to expand the values inside this, and now let's print this A. Now, now let's print this A. So A contains all value apart from John in it, and capacity remaining 10, but the values are 4 because only 4 values are there for sure. So this is how you can do some removal of objects from an slice, adding some object into slice. Now, I was discussing about one more thing, that is slices are of reference type. They are not as value type as the arrays were there. So let's consider that part also. So let's say I have names array and I have temp names array, and I'll make that as copy of names. Now, if names was an array and we change some index, let's say index 0 to value, let's say SUV. Okay. Now let's try to print the temp and the names. If names was an array, there should be something that you might be remembering, that the actual value in the names should not have changed. Temp name. Now when I go over here and let's see. So the first value in names is also replaced, but it was not the same case in array. In array, it was actually copying the all values into the temp name array. But over here in slice, they are actually a reference to an underlying array. So copying a reference variable to another reference variable will create pointing to same memory address, and that is where the same underlying array gets changed when you change the copy object of and slice. So when you use slices and you use arrays, both behave differently when you copy the values to the to new variable. So you should be very careful in using these two when you are writing a production ready program, because it might have a larger impact when you change some value somewhere. So there can be two different cases and you might get confused that why it is happening with this and why it is not happening with this. So you should be very careful in using this. So that's all on slices and arrays for today. Thank you for watching the video. Please do not forget to like, share and subscribe to our YouTube channel. Also press the bell icon so that you don't miss on any new notifications. Also do comment us below on any feedbacks or any new tutorials that you want us to do.